Okay, what I want to do at this point is let you know some key components to when you would use the different methods that we have gone over with systems. We've looked at when you graph, we looked at substitution, and we've looked at elimination. Okay, but we do know, here's what we know, that all systems can be solved more than one way. Okay, for some, a certain method probably is going to be the best choice. So what we want to do here is we want to take a look at a method and then just a hypothetical definition of when you use it and then give you an example. Okay, now again, these systems can be solved several ways, but let's take a look at. So the first method, we talked about graphing. When we graph, you want to use it when both equations are solved for y. So if you have y equals, like the example, 3x plus 2, then we know that we can just take the actual y-intercept, plot it, and then do our rise over run to the second point. Or better yet, we can take our TI-84, go to y equal, and input the actual equation and hit graph, and then we have it in front of us. Okay, here it says you want to estimate a solution. Then that means you're just taking numbers and plugging them in and see will it satisfy both equations. Okay, so what about substitution? When would be a good rationale? What would be an excellent time to use substitution? Okay, when a variable in either equation has a coefficient of 1 or negative 1. Okay, that means x plus 3y is equal to 7, or x is equal to 10 minus 5y. Okay, so we can easily again take this second term and substitute 10 minus 5y for x, and go on and solve for one of the variables, and then go back and put that in for the for in this case x, and then solve for y. So we say both equations is solved for the same variable, and either equation is solved for a variable. Okay, that's when you want to use substitution. Elimination. Both equation has the same variable with the same or opposite coefficient. That means we're talking about 3x plus 2y is equal to 8, and look at the second equation, 5x plus 2y is equal to 12. So you see both equation has the same variable with the same or opposite coefficient. And then of course all we need to do right here is really use subtraction here, and then we will change either one, the first equation or the second equation, and then we can solve. And then it's also say we use elimination when a variable term in one equation is a multiple of the corresponding variable term in the other equation. For example, 6x plus 5y is equal to 10. Now of course 2 and 5 are not multiples. We'd have to get all the way really to 10, but we could do easily with 6 and what? 3, because here all you got to do is multiply the second equation by a negative 2, and that's going to give us a negative 6, and we can take away that particular variable in the coefficient. Okay, so again, you guys write these methods down, take a look at when you see these methods, and then determine what type of methodology or what type of method you want to use to solve these particular systems. But again, you can always go back through these videos, but you need to write this down, put this on an index card or something, and you keep this with you at all times. What I mean by with you at all times, you just want to put it deep in the back of your membrane so you'll understand, okay, this is the way I want to do it. Now you may notice in class and class settings The way I look at them is I'm going to definitely use for a lot of mine, I use substitution, because I'll literally solve for a literal equation and then plug that in. That's just my way of doing it. Again, you have 1, 2, 3 different methods. You choose the one that's best for you. I hope you enjoyed this presentation on system by elimination, and we'll talk to you soon.